let's recall what's the definition of probability. The definition of probability is that P of an event E is the ratio between the cardinality of a set E and the cardinality of the set omega, where E is a subset of omega. So this is the definition of classical probability. And we know that this thing is cardinality of a set E, which means it's the number of elements in set E. So we are dealing with number of elements in a set. So that means what? That means classical probability is just combinatorics. So all combinatorics techniques you have learned carry over to probability. Here is an example. So suppose I toss a 6-sided die twice, so 2d6. What's the probability that the sum is 4? So suppose I have a 6-sided die, okay, then the sample space of this 6-sided die is 1, 2, 3, 4, 5, 6. And then the 1, 2, 3, 4, 5, 6 has the occurrence probability P1, P2, P3, P4, P5, P6. So for example, this P6 means the probability of getting a 6. So the generative function of 1d6 basically just this times x squared, and so on. For example, what does this mean? It means the probability of getting x5, or in other words, the output of the dice give you a 5 is P5, okay? And if the die is fair, that means we know that all the outcomes have equal chances. So we will have P5 equal 1 over 6. So what's the generative function of all possible outcomes of 2d6? That means you toss a die twice. It will be what? Product rule. The two polynomials multiply together. So gx of 2d6 will be gx of 1d6 multiply itself. So that means the whole thing square. So that means you multiply itself and you take the square. And we call that the notation. This thing refers to the coefficient of x power n. So therefore, we want sum is 4. That means we want the coefficient x power 4 of this thing. So it will be these three things. It will be first die give us 1, second die give me 3. First die give us 2, second die give us 2. First die give us 3, and second die give us 1. So these are all the possible outcomes you can have for two dice, such that their sum is 4. Then what will be the probability? It will be these numbers. So it will be these numbers. So if the die is fair, all the PI is 1 over 6. So this will be 1 over 6 squared, 1 over 6 squared, 1 over 6 squared. So it will be 3 over 36. That means 1 over 12. So this is the probability if we toss a die 2 times and then getting the sum is 4. The probability is 1 over 12. Now, so suppose I toss a fair 6-sided die 3 times. What's the probability that the sum is 13? Okay, recall that the 2d6 has this picture. These are all the possible results of tossing the die 2 times. And this is the corresponding generative function. Now, suppose I have 3d6. It will be what? It will be 2d6. Okay, this is error. Multiply 1d6. It will be all the possible outcome for 3d6. So that means for the polynomial, we have this thing. So if you multiply the whole thing, so for example, this one, multiply the whole thing, give you this row. Okay, this one, multiply the whole thing, give you the second row. This table, these are basically the multiplication between this polynomial and this polynomial. And this polynomial corresponds to 2d6, okay? And this corresponds to 1d6, okay? So these are all the possible outcomes. We are now asking what's the probability if we toss the die 3 times and the sum is 13. So that means we are looking for the coefficient x13 in this thing. So that means this guy, this guy, this guy, this guy, this guy, and this guy. So for the coefficient of this whole thing, the sum will be 6, 5, 4, 3, 2, 1, 21. That means out of all the possible ways that you can get for throwing 3 dice, okay, 3 dice, you have 21 ways. And then what's the size of omega? What's the size of sample space? You have 6 to the power 3. So the answer will be this number divided by 6 to the power 3. That is 21 output out of the 6 to the power 3 possible ways. That means this is the probability. So this is by picture. What about if we solve it by algebra? So now here is resolving this problem by algebra. So suppose the generating function for 1d6 is this polynomial. This die is fair, so all the p is 1 over 6, 1 over 6, 1 over 6, 1 over 6. So for the generating function of 3d6, that means tossing the die 3 times, it will be this polynomial power 3. Okay, and we are now looking for the coefficient x13 of this polynomial. That means we are looking for x to the power 13 of this expression. I have taken the 1 over 6 out, so we have the whole thing power 3 divided by 6 to the power 3. Then I move this 6 to the power 3 out, I have this thing. And again, all this thing, I have an x here. So I can perform factorization and I get x to the power 5. And since both of them have power 3, so I have a power 3 here. So that means if I want to have the x13 power of this whole thing, it's the same as I ignore this guy, but I ask for the x power 10. So that means we are now looking for the coefficient of this expression. So what is this thing for x10? So first we perform geometric sum. 1 plus x plus up to x5, it will be 1 minus x6 divided by 1 minus x. So recall 1 plus r plus rk minus 1 is 1 minus rk divided by 1r. Okay, here k is 6, so k minus 1 is 5. Then we have two terms, the thing on top and the thing on bottom. I split them, so I have this term and this term. Then from here, this bracketed term, the red term, I perform a binomial expansion. So I perform binomial expansion. So this will be my first term and this will be my second term. And since 1 to any power is 1, so I can ignore this guy. Then for this term, I just write it as a geometric series. So this is the geometric series. So now we are here. So for the first guy, it will be negative x6 power k. It will be just -1 and x6 power k. So this is -1k and x6k. So this is what I'm doing here. I'm splitting the negative x to -1 times 6. Then I have this, okay? So here I have a small mistake. This 6 should be in the x, not outside, okay? But here this is correct. So now let's focus on the blue part. Here I'm going to use a trick on expressing this blue term as a series of x to the power r. So what is this? This is the same as free choose r with repetition. So this is the coefficients, and this is what we have. I have a slide in the combinatorics on explaining how this is derived. So if you want to know why this is true, you can go back. So now from this thing, I'm just rewriting this as 2. So I get 2 plus r. N choose k is the same as n choose n minus k. So 2 plus r choose r is the same as 2 plus r choose 2. So now we get this. The reason I'm doing this to remove the r is that I want to remove as many unknown as possible so that it can be easier to manipulate. So now we have this thing. So what's next? We are going to combine the expression on x. So we have x6k times some number. So I will call this number c, and then I have xr. So it will be just c times x6k xr. So it will be just c 6k plus r. Combining the x term will give us this x to the power 6k plus r times all the coefficient in front of it. So don't forget, we are looking for the coefficient of x10. We are looking for the coefficient of x10. So suppose I have a number s that is 10, and I let it to be 6k plus r. So s is equal to 6k plus r. So what I'm going to do is that I know s is 10, so I have two unknown, one is k and one is r. So what I'm going to do, I'm going to eliminate one of them by writing one of them as a function of the other guy. For example, I write r as a function of s minus 6k. And don't forget, s is not unknown, s is 10, okay? So I first replace all the r by s minus 6k. So I have r here, I have r here, and I have r here. And by replacing with the red bar, I have r become s minus 6k, r become s minus 6k, and then r become s minus 6k. Together with the 6k, it will be s. So now we have this thing. So I'm now writing everything on s, okay? And since s is 10, so we have x to the power 10 of this whole expression. Here you can see that I only have one unknown, that is k. And k is actually not an unknown. K is limited by this guy. So what is this guy? This is saying that I start from k equal to 0, and then k equal to 1, and then k equal to 2, and then k equal to 3. And also notice that what is this guy? This guy means I have 12 minus 6k choose 2. 12 minus k choose 2 is non-zero only if k is 0 and 1. Think about it. If k is 1000, this is a negative number. Negative number choose 2 is 0. Okay? So therefore, this expression only exists for two numbers, 0 and 1. So what we have is we put k equal to 0 and 1 into this expression. So what we're going to do is we put k equal to 0. So we have 3 choose 0, -1 power 0, and then k is 0. So 12 choose 2. So we have this term. And then we put k equal to 1 to here. That is 3 choose 1, -1 to power 1, and then 12 minus 6 choose 2. That means this term, this whole thing gives us -3 to 6 choose 2. So I have this thing, and then I subtract them. It will give me 21. This is exactly the same solution, 21 over 6 to the power 3, using the figure.